Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, I'll be tackling the 10th question from the King David High School preliminary exam, which was written in the year of 2023. Please do expect a total number of 12 videos, since the question paper had 12 questions in total. That simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and, most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, we are supposed to determine the coordinates at which f of x touches the two straight lines. Okay, we are supposed to find the coordinates at which the graph of f of x is tangential to these two straight lines. Are you together? Okay, how can we do so? Firstly, we can find rather the derivative of each line. Né? If this is line 1 and that is line 2, let's deal with line 1 first. Né? For line L1, I can simplify the derivative of line 1. The derivative is basically y minus y1, which is just equal to x2 minus x1. Are you together? I do have two coordinates on the line, so that's basically 3 minus 0 and 0 minus a negative 3. I'll simplify a gradient of 1. Are you together? And then that point of intersection of the two lines, guys, is also the y-intercept of both lines. So therefore, the equation of line L1 is basically mx plus c. The gradient is 1, so I'll just say that's x plus c, which is the y-intercept. That's just equal to 3. This is the equation of the line, guys. Né? Okay, now let's go and find the coordinates at which this line y is equal to x plus 3 is a tangent to the curve. Remember that, guys, the derivative of a curve is always equal to the gradient of a tangent, to the curve at a specific point. Are you together? So if I can say f prime of x, this will be equal to negative 4x. Are you together? That means the derivative of a tangent at a specific x value is just equal to 1. I want to know the actual point over there, né? Because the gradient of my tangent is 1. So I'll therefore say 1 is equal to negative 4x. Therefore, x is basically equal to negative 1 over 4. I now know the x coordinates. Let me call this point A. Né? The x coordinate is just negative 1 over 4. Now I want to find the corresponding y value. I can simply use the equation of my line to find the corresponding y value. I want to find the corresponding y value if x is equal to negative 1 over 4. And then this will just give me an answer of 12 minus 1. That's 11 over 4. So the corresponding y value over there is 11 over 4. Let's go, guys, and do the same thing for line L2 and find the coordinates over there. We'll call this point B, the point of contact between the tangent and the curve. Okay, for line L2, guys, we do the same thing. Firstly, okay, for line L2, né? The gradient of the line is also y2 minus y1 over x2 minus x1, right? Over there, we can simply say we have 3 minus 0, and then 0 minus 3. This will just give us a negative 1. So the gradient of line L2 is just equal to negative 1, and hence the equation of the line, let me use a different color over here, that's y is equal to negative x plus 3. Remember that the two lines have a common y-intercept, right? Okay. This line, guys, is a tangent to f of x. So I want to find the point at which the line negative x plus 3 is a tangent to f of x. I know that the equation of f of x is basically negative 2x squared plus k. Are you together? I can simply find the derivative of my graph. That's negative 4x. But I know that the derivative of a curve is always equal to the gradient of a tangent at a specific point. I know the gradient of my tangent. I can therefore find the x value at which the tangent is in contact with the curve. The gradient is just equal to negative 1. That's equal to negative 1 is equal to my derivative, and hence x is basically equal to positive 1 over 4. Now I know that the x value there is just positive 1 over 4. For me to find the corresponding y value, I am just going to use the equation of my tangent. So that's simply y is equal to negative. Whenever I come across x, I'll just substitute 1 over 4 because I want the corresponding y value when x is just a positive 1 over 4. And the answer over there will simply be also 11 over 4. So these are the coordinates, guys, whereby the two lines are in contact, or rather whereby the two lines touches the graph of f of x. These are the two coordinates. That's how, guys, we're supposed to deal with that question over there. Okay, and then now we are given that f of x and g of x are both parabolas, and we are told that f of x is equal to negative g of x. Okay, so this simply means that for me to obtain the graph of f of x, I just need to reflect the graph of g of x on the x-axis. This statement over here tells me that. Are you together? And whenever I reflect my graph on the x-axis, only the values of y changes the sign. Okay, let's see the properties that you are given there. We are given the y-intercept. This value over there is the y-intercept. Why? Because when x is 0, x is only 0 on the y-axis. So I know now that my y-intercept is basically below the x-axis. That's negative 3. And then I'm also given the values of x that will give me 0 whenever I substitute them. Usually these are called my roots, and the roots of a parabola, guys, are called the x-intercepts. Are you together? So if guys, my y-intercept is below the x-axis and both of my x-intercepts are on the right hand side, this simply means that my graph should just look like this. My graph should just look like this, né? Whereby I will have negative 3 over there, and then this will be just 2, and that's 6 over there. This graph is the graph of f of x. Are you together? And then I can simply find the x value turning point, because I was told that the derivative of x whenever x is equal to a, we get 0. The derivative is 0 only at the turning point, right? So that means the x value at the turning point is a, and the corresponding y value is 5. But wait a minute, guys, we can find the actual value of a, even though it's not necessary for us to find it. The x value, guys, at turning point is always equal to the average of my x-intercepts. So the first intercept, the first x-intercept is 2, the second one is 6, divide by 2, and then just get 4. So the x value at the turning point is basically equal to 4. This over here, guys, is the graph of f of x, but I was never asked to find the graph of f of x, right? Remember that, guys, the graph of f of x is just a reflection of g on the x-axis. If ever I reflect on my x-axis, only the sign of y changes. So I'll simply have a graph like this. So my graph will simply be like this. The x-intercept will be the same. The only difference will be the y-intercept. Now the y-intercept will be positive 3. And then for the turning point, I still have the same x value, but the y-intercept has a different sign. So the red graph, guys, is my g of x. So I can simply erase the blue graph over there because I was never asked to draw it. It was just helping me to draw the red graph. So that's how, guys, we're supposed to tackle this question over there. And then now we are told that hence if h prime of x is equal to g of x, state the values of x for which h of x will be increasing. Okay, now they're saying to us, guys, g of x is equal to the derivative of h. Are you together? And I know that, guys, the derivative is always increasing if and only if it is greater than 0. Are you together? So therefore, since they are both equal, I can simply say h of x is increasing if g of x is greater than 0. Are you together? Since these two things, guys, are equal, that means when h prime of x is positive, g of x will also be positive. Are you together? So basically, I know that whenever g of x is positive, that means the graph of h is increasing. Are you together, guys? So I know that g of x is only positive above the x-axis. Excuse me. G of x is only positive above the x-axis, and I can only find g of x above the x-axis over here from the left of that x-intercept and also from the right of that x-intercept. Are you together? So we'll simply say the answer is just x is less than -2 or x is greater than 6. These are the two solutions, guys, whereby our graph of h of x is increasing. X less than 0, not than 0, man, excuse me, guys. X is less than 2 or x is greater than 6. Are you together? Okay, then now let's go and answer the last question. We are given the log of y base 3 plus the log of x base 3 equal to 2. We are supposed to use your knowledge of logarithms to sketch the graph, paying attention to any restrictions. Okay, I have log of y. I have I have the log of y base 3 plus the log of x base 3. This is equal to 2. There's a rule, guys, in logarithm that simply says if ever you have log a, log b base a plus the log of c base a, this can be written as the log of b times c base a. Are you together? So I can simply say this is just the log of y multiplied by x, or I can say x times y base 3. That's just equal to 2. Are you together? I can simply remove this logarithm of mine by simply making the 3 the base on the other side. I'll end up having xy is equal to 3 to the power 2, and hence xy is just equal to and hence xy is equal to 9. Therefore y is just equal to 9 over x. Are you together? This kind of a graph, guys, is called the hyperbola. Are you together? But before, guys, before I draw my graph, I should apply any restrictions. For a logarithm, guys, the index of a logarithm should always be greater than 0. Are you together? So both x and y are greater than 0. These are my two restrictions. These are the two restrictions. Are you together? So I just have to draw this graph over here. This hyperbola. I know that whenever the hyperbola is whenever the hyperbola has a positive constant, that means the graph is always in the first and third quadrant of my asymptotes. Over here, the Cartesian plane is my asymptote because there's nothing added or subtracted next to x, as well as we don't have any any vertical shifts over there. Ne? So the Cartesian plane, guys, is our asymptote. So our graph will just simply be like this or like that. Together. But since, guys, we're told to apply restrictions, I want to draw my graph where both x and y are positive. And that means my graph should be only in the first quadrant. So because there are restrictions, that means I'm supposed to remove this part over there. I'm supposed to remove that part over there. And obviously, guys, if my graph does not cut both the x and y axis, I must just indicate an extra point. I'll choose any point over there. I know that whenever x is 1, the corresponding y value will be 9. So that's how, guys, we're supposed to deal with this question over there. So please, guys, do stay tuned and wait for more videos. Thank you.